There we go. We're recording. Second here. Okay. Happy Thursday, Thursday week one. I believe everybody in this room currently has done it, but anybody else, if you have not finished the chapter one assignment, get that done. Today is the last day. I think you both have done it, so we're good, but I've got to say it. Um, so tonight is going to be a full night, but it probably won't be any longer than Tuesday's class. And I feel like Tuesday's class was actually a nice length. I try not to go later than 6:30 or 7, so it was pretty much perfect. Okay, today we're going to finish up chapter 2. We're going to do section 2.2. We're going to do some more organizing things in tables and histograms. We're going to do something called a stem and leaf plot. And we're going to, oh, sorry, I have Iron Man in my hand. My grandson left it on my table. And then we're going to identify the shape of the distributions. Then we're going to jump into the beginning of chapter 3. We're going to look at mean, median, and mode. There's lots of cute little like songs and stuff on YouTube that help you remember them with mnemonic devices if you need them. But I haven't seen many people have issues with them. So hopefully it'll all work out just fine. After that, it's not on the screen. It doesn't say it. I'm going to write it on here because this is important. Lab one. We're going to do lab one at the end. I will walk you through the Excel for lab one. Hopefully you've all collected your data. If you haven't, that's okay. It's not due till Tuesday. So you still have the weekend. Right, so that's what we're going to do today. We're going to jump right into it. We're going to start with some discrete data. So this is talking about how many cars people have in their houses. So we took a random sample of 50 different households. I'm assuming in the US, but it doesn't say. I'm just making that assumption. And we're looking at how many cars they have in their household. So this data is discrete. On Tuesday, we were looking at categorical data. We're going to look at quantitative today. So everything or almost everything we do today is going to be quantitative until we get to mode, but most of it's quantitative. So first we're going to look at discrete and then we will jump into continuous. So this is just my raw data. It is not cooked in any way. It is just a list of the answers. I'm going to go to the next screen. So here's my frequency table. You may recall from Tuesday, we just take each data value we get, each point that we got, and count how many times it showed up. So the people with 0 cars showed up 4 times. With 1 car shows up 13 times, etc., etc. So the frequency is just how many times it shows up. And then, so we have those counts. You do not need the tally marks if you're doing your own frequency table. Sometimes it's just helpful. If you have them, it's not a big deal. If you don't, it's not a big deal either way. Then relative frequency. Relative frequency, you take the frequency, then you divide it by the total number of data values. Ours was a sample of 50. So for 0 cars, we did 4 divided by 50. We got 0.08, which is also 8%. I don't care how you write it. My open math cares how you write it. I don't care how you write it, but this is what it is. All right. So, one thing that you're going to see in your homework, and this is something I don't normally put in the lecture, but I've gotten a lot of questions about it, is cumulative relative frequency. So, cumulative is just added up as you go. So, they would just take these relative frequencies and add it up as you go. So, this one still 0.08. But then the next one, we would take the 0.26 plus the 0.08, and it would be 0.34. So this right here is the proportion that are 1 or fewer. And then so for 2, I would add the 44. I would get 0.78. So 78% of the households that we surveyed have 2 or fewer cars. And then it's just so on and so forth. Then you add it here, 0.92. And then we just add it, and the bottom one's going to be the 100%, 0.98. 1.00. So 98% of the people that we surveyed had four or fewer cars. So this is cumulative relative frequency. So you'll see that in some of your homework assignments, and it just means to add them up as you go. And it's a great way to be able to tell that number or fewer. I think I'm trying to remember the example of where we find that, and I can't remember. So, okay, so that's the cumulative relative frequency. I'm going to move on. Okay, so we did a bar graph on Tuesday, and a histogram is very similar to a bar graph. You could almost say it's a type of bar graph. So we do the same thing we did with the bar graph. We draw rectangles. The height of each of the rectangles is the frequency or the relative frequency of whatever it is we're looking at. And the width of the rectangles are all the same. But the difference in it visually here is that all the rectangles are going to be touching each other rather than have. So with our bar graphs, I'm going to draw you a really gorgeous bar graph here because my drawing skills are excellent. Kidding. Then my drawing skills are terrible. So this would be a bar graph, as if a histogram would look something like this. And obviously I'm not using the same data for my two graphs, but a histogram is going to look like this. So all of the bars are touching each other. Most of the time, we use histograms for continuous data. In this example, we're going to use it for discrete, and it is occasionally used for discrete, but most of the time we use histograms for continuous data. And yeah, so there we go. I'm going to show you a histogram for the number of cars people own. So once again, here's our frequency and our relative frequency. The far left is the number of cars. Here's my histogram. So notice I have a title. This is required, a title. I have axis titles. Those are also required. This right here tells you the values in each of those bars. So number of cars, my number 2 right here, it looks like it goes up about up to 22 there. This is the histogram. The bars are touching each other, and it's very similar to the bar graph. And a histogram with discrete data looks almost exactly like a bar graph, except for those bars are touching each other. Continuous data is going to look a little bit different. And unfortunately, I don't have a super good continuous graph in here, and I meant to add it in, but it didn't happen. So I'm going to try to, I'll draw one in a little bit once we get to continuous. So this is for our discrete data. This is what the histogram looks like for the discrete data. Okay, this was relative frequency. This one's frequency. That one's relative frequency. Same thing, except for we just have the relative frequency over here instead of the frequency. So it's basically, it's the same thing. Okay, let's move on. So classes. So this is when we're dealing with either discrete or continuous data, or if we have like a large number of values of it's continuous data or a large number of values of discrete data. So if I think I have an example. I don't want to try to come up with something off the top of my head. So classes are also known as they're also known as bins. In Excel, we call them bins. Classes and bins are the same thing. You're going to probably hear me call them bins more than classes because usually when I'm dealing with histograms, I call them bins. I think that my open math calls them classes, but it's the same thing. If you hear bins or you hear classes, it's exactly the same thing. So when we have either a large number of different discrete values, or if we have continuous data, we have to create classes based with intervals of numbers. I'm going to have an example here in a minute. So we do intervals of numbers so that multiple numbers are represented by one of our bars in our histogram. this, so as it says, large number of different discrete data values or with continuous. So here's the example. So this is the people who are currently work disabled. So our ages here, I could put each individual age, 25, 26, 27, 28, all the way up to 64, but that would be a really ugly, ugly histogram. And when we are doing graphs, it's really about aesthetics and how meaningful the data is. So we want those two things. We want it to look nice and we want it to be meaningful. Those two things are important. So here I have ages from 25 to 64, and this is how many of them in thousands are work disabled based on our poll or whatever. So the lower class limit. So this number right here in each of my bins or classes is called the lower class limit. It is the smallest number in the class. I know, it's a real stretch there. The upper class limit is the largest number in the class. So that's the upper class limit. So that's the highest value that's in that bin is the upper class limit. So our very first bin, our very first class has 25 as our lower class limit and 34 as the upper class limit. To determine the class width, you would take the lower class limit of two consecutive classes or two consecutive bins and you just subtract them. All of our bins have the same size interval. So it doesn't matter which two I grab, but if I grab that one and did 45 minus 35, you'd see that there's 10 in each one. I could do 35 minus 25. It doesn't matter, just two consecutive. So two in a row to determine how wide our bins are or bins or classes are. That gives us our class width. All right. Questions so far? Are we doing okay? All right. You guys just jump in if you have questions. Okay. I have some data here. So this is the time between eruptions for a random sample of 45 eruptions of Old Faithful geysers in Wyoming. We're going to construct a frequency and a relative frequency distribution of the data. And then we're going to play with the bins a little bit. And that's really like the purpose of using this is to kind of play with the bins. Okay. So my smallest data value is 672 and the largest is 738. So as I said before, part of our building graphs is to make it pretty. We don't want to start with a number like 672. We just don't want to. Now, if you're doing this in Excel, it is always just going to start with the lowest data value. But if we're doing it by hand, we usually go with, I think they say like the most convenient number. We find a pretty number just below our lowest value. So we're going to use 670. And then I usually try to pick a nice number for my class width, something that's going to make it visually appealing. And I'm going to show you things that make it not visually appealing as we go. So I want it to be visually appealing. So I'm going to make my class width 10. So this is a really nice, pretty round number. And I'm going to start with 670 and I'm just going to go until I've encompassed all the numbers. So here we go. So here are my bins. Went from 670 to 679, 680 to 689, all the way up to 739. That encompasses the 738, which is my highest number, and 672. So they're all contained in there. So this is nice. It gives me seven classes. That's really good. We generally want, I think that they say between 5 and 20 classes. I think that 20 is too many. So for our class purposes, I want you to have between 5 and 12 bins or classes. That's what I would like you to have. When you are creating a histogram in Excel, I'm going to want you to have between 5 and 12 bins and classes. And I want you to do it, it needs to be meaningful, and you'll understand it as we go. Meaningful and I would like it to be pretty, but I'm going to be pretty lenient on that. And I'll show you what I mean as we start looking at the frequency tables. So I'll give you a pretty good example, and I'll show you on when we're doing Excel. Right. So here's my frequency table. So what we're trying to do when we are creating our bins, where we're setting up to make a histogram, what we're trying to do is to make it so that we don't have very many empty bins. Now, it's inevitable. We will occasionally have empty bins. It happens. But you definitely don't want like three in a row or something like that because that's just ugly. It's not visually appealing. So, and plus it's going to sometimes it just makes us have way too many bins. Occasionally, you can't help it. There are times when you just can't help it. There's not a way to make it both meaningful and visually appealing. So if you can't have both, go for meaningful. So if you can't have both meaningful and visually appealing, meaningful wins out. So here I have one empty bin. That's fine. This actually looks really lovely. If I create my histogram, it's going to look really nice because the only empty bin is that one. So I'm going to change my bin size. I changed it here to 5. Now, think about what this histogram is going to look like. I'm going to have 3 empty bins in a row. So there'll be 3 different intervals where there is no bar for the bar graph. That's going to look really ugly because I'm going to have a couple of them here, big empty spot there, and then I'll have all the rest of them. That's ugly. We don't like that. We're going to stick with 10. Plus this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. And that feels like a lot. I think feel like that's too many bars. It's going to be just a lot. So I would, if it was me, if I was creating the histogram, I would do this one. I would stick with the 10 because it's going to be visually appealing and I'll still get some meaningful results out of it. This one right here, it's going to be somewhat meaningful, but it's not going to be visually appealing. I mean, it'll be pretty meaningful, but it's so spread out. I don't think we need to go down to 5 seconds. I feel like 10 seconds is good enough to look at how frequently the distance between the eruptions. You got to think about what you're showing and what you really need for your purposes. Since we're not actually doing anything with this data, I'm not applying it to anything. I'm just looking at, hey, how often do we have eruptions of Old Faithful? 10 seconds, I think, is adequate, especially since we're looking at 670 seconds is our lowest. 5 seconds here and there is not going to make that big of a difference. All right. All right. So I'm going to tell you our curriculum finds the bin width a different way than I do. I'm not a fan of the way our curriculum does it, but I'm going to show it to you. And if you like it, go for it. I'm not a fan. Okay. So now they say choose a convenient number. I always choose a pretty number. So for example, we had 672. We chose our lower class limit of the first class to be 670. You absolutely can just choose 672 as your lowest, the lower class limit of the first class. You can if you want to. Usually, though, we will choose a pretty number. Like we are at 672, we chose 670. If I had a number like 604, I would probably make it 600. You just choose a pretty number that is right below your lower class limit. Like or right below your lowest data value. So just choose a nice pretty number. That's how we find our lower class limit of our first class. I'm going to show you how our curriculum finds the width, but I don't like it. You'll see why in a second. All right. So here's what they do. So see, they say between 5 and 20 classes. I like 5 and 12. The Our curriculum thinks that you should choose the number of classes you want first. So choose how many classes you want. You decide, I would like to have 10 bins. I want 10 bins or 10 classes. So you would take your, say, okay, I want 10 bins. I'm going to put that right there. I want 10 bins. And then you take your largest data value, that was 700, what was that? 738? 738. You take your highest number, you subtract your smallest number, and then you divide it by the number of bins you want. When that happens, my bin width is 6.6. How annoying would that be? How annoying would that be if my bin width was 6.6? I really, really dislike that. This is not how I determine my class width. Not at all. What I do instead is I decide on my class width and then say, okay, when I divide this, if I choose 10, that gives me 12, that gives me 12 bins. That's perfect. I like that. I will just choose a class width that's going to get me between 5 and 12 bins. That's what I do. I go by class width first and just choose what class width I want, and we end up with the number of bins we end up with. I don't want a 6.6 for my bin width, if that makes sense. You absolutely can have it if you want to. I will let you. I will say, go with it, have fun with it, but it's not my way of doing things. So you can do it either way. You can choose. I am going to do it this way and get a 6.6 bin width. Absolutely. Or, and I'll have 10 bins and it's going to be lovely. Or you can say, I want a size 10. I want a 10 width to my bins. And however many classes I end up with, that's great. Because the thing is if I chose a 10 bin width and then I ended up like with only two classes in my histogram, like, okay, I need to make my bin width smaller. I'm going to try three. Or you can say, if you have a 10 bin width and you end up with 25 different bins, you can be like, okay, I need to make my bin width higher. Let's try 20. So you can just adjust it afterwards, especially if you're using Excel. We can adjust things all we want and make it as pretty as we want. And I'll show you how to do that as we get there. All right. Are we doing okay so far? Any questions? All right. I see. I see you. Okay. So with this right here, I believe this is gonna show you an example of an Excel created histogram. So this histogram is created by Excel. I did not create it, just letting you know. It's not going to be beautiful, but it's okay. Just want to kind of show you what the Excel one looks like. So you're considering investing in a Roth IRA. You collect the data in table 12 on page 79. So if you have the textbook, it's on page 79. Don't even worry about it. It's this table right here. So this is the 5-year rate of return for a simple random sample of 40 blended mutual funds. We're going to construct a frequency distribution, and then we're going to do a histogram. So here's my first frequency distribution. I made my bin width 1, and so it's 1%. I do have 2 in a row, and I started thinking about this. I thought about making my bin width 2% instead, but then I thought about this and was like, I think with interest rates, I like the idea of all of the eights being together than all of the nines being together. I feel like having 2% together was less meaningful. So when I said, if you have to decide between meaningful and pretty, go with meaningful. So I went with meaningful, and I do have these two ugly empty bins together right there, but that's okay because meaningful wins out in this case. So it's just one of those things where you have to weigh it. And in this class, I'm not going to make you split hairs there, but so just go for pretty. But if you're in your regular life, because that's what we're your career is what you're training for, go for meaningful over pretty if you need to. Okay, here's the Excel histogram. I did not label my axes. So Excel starts with the lowest value. It did make its bin width 1, but it starts with the lowest value. Excel also shows you both edges. What I don't like, I'm going to make this bigger. I don't like that 9.28 is both here and here because technically it's not. Technically, 9.8 is only here. That's the lowest class width, the lowest class value. I forgot the whole word. Anyway, that's the lower class limit. That's the word. The lower class limit is 9.28. So technically, this one right here goes from 8 point, oh, that's ugly. Let's do this. This one technically goes from 8.28 to 9.27, technically. And the way these are normally labeled, so give me a second because I'm going to relabel these. And we're going to pretend that I made this the way that I wanted to make it. Oh, let's get rid of this. Come on, erase it. Okay, erase all of that. I'm going to put on a white pen and get rid of everything that I don't want to see. And I'm going to show you how these really should be labeled. Okay. So we are starting with, and plus it should not start with a number that's not 0 all the way to the left, but Excel does that and it's kind of annoying. Okay, so my lowest interest rate is 8. So the way we would really label these is I would put whoa, I didn't change my pen size. Okay, you would label this as 8. That's still not small enough. Come on. Sorry. Okay. No. Okay. You would label this as 8. You would label this as 9. We only label the lowest bin width, the lowest class value. We only label the lower class value. That's, ugh, stop it. So then this one right here would be 16, 17. We only had 2, right? And then 18. I think that's what it was. So we only label the lower class limit. So you know that it's going to go from 8 all the way up, butting up against 9. And then it goes from 9 all the way butting up against 10, but not at 10. And then 10 all the way up to 11, but not equally 11. This is normally the way you would see it. It would not be the way that Excel has it, even though that's what Excel does. But when you are doing your homework, this is the way it's going to be listed. So these right here are the lower class limits or class values. That's what it is. Those are the lower class values. So the 9 is the beginning of the second bin. 10 is the beginning of the third bin, et cetera, et cetera. Does that make sense? All right. I'm going to move on. Maybe. Boop. There we go. Okay. I need to give you a little bit of a disclaimer before we do stem and leaf plots. Stem and leaf plots are something that I have yet to find value um, with. I don't find them super valuable. I've never had a set of data that I was like, you know what, the best way to show this is with the stem and leaf plot. It is part of our standards. There might be a question or two in your homework. You will not be tested on it at all. I'm going to show you stem and leaf plots on a few slides, and then it's going to go away and I will never bring it up again. These are like my least favorite type of graph. I don't find them super useful, but they are a thing. So what we have is we have basically like a vertical line. On the left are the leftmost digits of whatever data you have. Those are going to be called the stem. The rightmost digits will be on the other side of the line, and those are called the leaf. I will show you how to set it up in a minute, and you will see. And however, if you find think of some data and say, hey, this is best represented by a stem and leaf plot, share it with us in the discussions. Or maybe you see something set up and you're like, this is perfect for stem and leaf plots. Please show it to me because I would love to see something that's best represented by stem and leaf plot because I have yet to see it. And I've been around for a little while. I'm kind of an old lady. So, I mean, I am a almost 9-time grandma. So I've been around a little bit. So, right, here we go. So we're going to look at the geyser eruption data. The stem portion will be the stem portion of my stem and leaf plot is going to be the hundreds place and the tens place. The leaf is going to be the ones place. So here's my data right here. I put it in order from smallest to largest because I wanted to make it a little bit easier. So you're probably either going to want to arrange your data smallest to largest to begin with, or you're going to create two stem and leaf plots, one not organized and then the other organized, because it's kind of a lot of work if it's disordered. Okay, I'm going to show you with it organized first. So this right here, like this would be 670. This is 700. The reason I have two of the 720s is because that set, when we have one of our like sets that is like too long, I think that that decade, the 720s, is super long. So I split it into two. You don't ever have to split it into two, but we frequently do that. So the first 7-2 will be from 720 to 724. The second 7-2 will be 725 to 729. All right. So my first data value is 672. So I'm going to put a 2 right there. My second data value is 678. I just put the 8 right there. There's no commas. They're just ordered from smallest to largest, and it's just the ones place. There were no 680s. 690. I had three 695s. Yes, you put all three of them there. I have a 696, 698, two 699s. For 700s, I have two 700s, two 702s, whoa, 703s, 706, 708, 709. I'm just going to put these ones here. As I said with the 720s, I'm splitting them up. So I have 720, 721, 722, 723, and then 725 is going to go down here. And then last. Every data value is represented by one of the pink numbers there, every single one of them. We just list them smallest to largest, and it's just like this. This is how we do it. Now, every time you draw a stem and leaf plot, you need to have a key. For the key, write the word key, and then you pick any data value. I don't care which one you choose, you just find your favorite. I'm going to say 7, 2, 8 represents 728 seconds. This way, anybody looking at your stem and leaf plot can kind of understand what it's representing, what each one means. That way they can look at that and go, okay, so if 7.2/8 is 728 seconds, then 735 must be 735 seconds. That way they can read it. Before I do another one, do we have questions about this one? All right, moving on. All right, so this is the unemployment rate in the 50 states. It looks like we don't have Washington, D.C., so it's just the 50 states. We have our unemployment rates. I am not going to write all these out. I actually have them printed on the next screen. So in cases where we have a decimal like this, the whole number portion will be my stem and the decimal portion will be my leaf. This, in cases like this, a key is super important. So I'm going to have the stem be the whole number and the leaf be the decimal. So here's the disorganized. So I just kind of went through and just took them from, this is kind of like a raw data thing. It hasn't been organized yet. These are not numerically from smallest to largest. They're just kind of all over the place. And I probably could have split the five into two, but I didn't do it. So then after you make your super disorganized one, then you're going to pretty it up a little bit. Once again, we like things pretty. So there we go. So now it is organized smallest to largest. Don't forget your key. Looking at this, you're not going to understand what these numbers stand for. So you pick a random value. Write the word key. So I'm going to pick 54. 5.4%. There we go. Now I have a key. So now when you read this, when you look at this stem and leaf plot, you're going to understand what it is. That is the end of stem and leaf plots. So if you have any questions about them, now is the time to ask. Obviously, at the very end, if you have one, you can do it. So if you find one in the wild that you say this is the perfect data to be represented by stem and leaf plot, I'd love to see it. I'm sure your classmates in the discussions would love to see it. And I'm not going to talk about them anymore. I'm going to move on. All right. Shape of distribution. Now, this is a topic that will keep coming back. We have several topics throughout this term that keep coming back. This is one of them. It will keep coming back over and over and over. So hopefully this is something that you can grasp easily and just carry it with you. Keep this one with you. So when we look at a histogram or when you look even at data values that are like stem and leaf plot actually is a pretty good example of this. I know I said I wouldn't say it again. Anyway, so you kind of look at the shape and it helps us. There's a lot of different ways that we use this, but right now we're just gonna look at the shape and say, hey, that's pretty, and name them. So our first way to describe this one right here, it just looks like a rectangle. This one is symmetric, but it is a uniform distribution. All of my bars are the same height, so it's uniform. Now, statisticians love adverbs. So, adverbs are usually they're words that describe an adjective, or you can say that words that end in ly a lot of times. So it could be mostly uniform or virtually uniform or whatever. It can be basically uniform and still be called uniform. So like I could have one of my bars could be slightly higher. And maybe I have one slightly higher and then I have another one slightly lower. But if it is basically a rectangle, we will call it uniform. Sometimes they're not exactly uniform, but they're really close. So we could call it uniform, if that makes sense. So maybe I had, my values in here is 21 instead. Then this one down here is 19 instead. Still basically uniform. So we would call it uniform. Next one. This one is lovely. This is the gold standard. This is what we want to see. This is what we use the most in this class, a bell-shaped distribution, also called normal. Normal or bell-shaped. Once again, it is symmetric. Symmetric just means that if I draw a line down the middle, and if I folded it on itself, it would land flat on itself. My sides, the two sides would mirror each other. So this is nice, pretty. It's called bell shape because I can draw a nice, pretty bell over top. My right tail and left tails aren't longer than each other. and it's really nice and beautiful. Now, once again, it could be relatively bell-shaped, mostly bell-shaped, practically bell-shaped. If it pretty much is bell-shaped, we will call it bell-shaped. We don't deal in exacts. This is not one of those exact sciences. There's some wiggle room here. If it's mostly symmetric and mostly bell-shaped, we will call it mostly bell-shaped or relatively bell-shaped. So it's not an exact science. And I know that drives some people crazy. It drove me crazy for a long time because I'm very type A and I like things to be black and white, cut and dry. But this is just it is what it is. And I've learned to find the beauty in it. All right, next. This one right here. When we have a long tail on one side, it's skewed, but this one is skewed right because our tail is on the right. It seems exactly the opposite of what it should be, but just think about where's that long tail. So in this one, our long tail is on the right, so we are skewed right. That's all there is to that one. This one, notice that we have a long tail on the left, long tail on the left, we are skewed left. I know that personally I like to try, I tr really tried to say, hey, this has to be right because my peak is up higher on the right. No, 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 no. You're looking at the tail, not the peak. The tail is what is important here. All right, so let's take some guesses. So here, take a look at this distribution. Think about what it might be. If you got bell-shaped, pat yourself on the back. Great job. This one is bell-shaped. Good job. Yes. I love it when you type it in the chat. That's the word. I love when you type it in the chat. All right, next. Think about this one. What do we have here? Yay, this is skewed right. Good job. My tail is over here on the right. Skewed right. I love it. All right, let's do the next one. Think about that. We've kind of got like getting process of elimination here also. Yeah, this one has the tail on the left, so this one is skewed left. I bet you, without me even showing it, you can guess which one the next one is, but I'm going to put that on there anyway. Here we go. Nice, pretty rectangle. This one is, uh-oh, this one is uniform. So questions about the shape of distribution before I move on. All right, so we're going to be using these shapes a lot as we move forward. It's going to come up more probably in later chapters than in the earlier chapters, but it's very important. It really is. All right. So we are done with chapter 2. So you have enough information to do the 2.2 homework. We are done with chapter 2. It is done. We're going to move on to chapter 3. If you keep track of that sort of thing. All right. So we're going to center ourselves now. We're going to do measures of central tendency. So we're in 3.1. So we hear the word average a lot. And a lot of times people don't even think about what it means. They automatically think that every time you say the word average, it's just you add them all up and divide by how many there are. But we have 3 different ways that we can calculate it. There's 3 different centers, and which center we use depends on our data and depends on, well, a lot of people use the wrong one in order to mislead people. Happens a lot, but we're going to figure out which one makes sense, which center makes sense, and how to calculate them all. Thankfully, I'm sure you've all been taking the average of things your whole life. So the mean, which is our normal word for average, is the first thing we're doing, and you probably already know how to do it. So here we go. So arithmetic mean, I very, very rarely say the words arithmetic mean. I usually just say mean. We add all the values together and divide it by how many data values we have. So we have a couple of symbols here. The population mean is this symbol right here. It is a mu. When I draw it, it looks like, yeah, that one's really ugly. It looks like that, which is it's kind of similar, but it's more italicized, I guess. And it's going to get uglier and uglier as I move along. So kind of a rule of thumb here, if it is a population value, it usually has the fun symbols like mu or sigma or whatever, the nice Greek letters. If it is a sample, it usually has the boring symbol. This is for a sample. This is called an X bar. That's all. We call it X bar. When we're calculating the sample mean, we label it with X bar. So the population mean is a parameter. Remember, parameter, population. If we're dealing with population, it's a parameter. If we're dealing with a sample, it's a statistic. So the sample mean is a statistic. The population mean and the sample mean are calculated exactly the same way. I'm going to write this down because this has been an issue for people for some reason. Exactly the same way. There you go. They're calculated exactly the same way. Add all of them together, divide by how many data values there are. They're calculated the same. They just have different symbols depending on if it's a sample or a population. That's it. All right, I'll give you a second. All right, let's move on. So this is just the formula. This right here just means add them all up. That's all it is. It just means add them all up. That big sigma. That's a capital sigma. It just means add them all up. Don't even worry about it. So if you get a decimal for your answer, kind of standard practice is you round to one decimal place farther than your raw data. So if I'm counting the number of kids people have and then I'm averaging how many kids they are, I could get something like the average is 1.5 kids. It's okay. It's okay to get an average that's weird, especially with discrete data. You get weird averages all the time. It's okay. We just round one more than our raw data. Now, my open math will tell you what to round to, but so no worries there. All right, let's do an example. So we don't need to use the fancy calculators, but if you want to, go for it. I'm going to use the fancy calculator. I'm just going to use a regular, but I will use the fancy. So take all of these. There are 7 employees here, 7 people. We're going to add all 7 of them up, and then we're going to divide by 7. So 23. So my total, 151 divided by 7. I think, did I get them all right? No, we didn't. Ignore my numbers. Ignore my numbers. I missed one. I am the typo queen. 174, that makes much more sense, divided by 7. So my average here, 24.9, because I'm rounding to one farther. These are whole numbers, so I round to the first decimal place. So that's the population mean. So it wants us to take a sample of 3 employees. Just take 3 of them. I'm going to show you something really cool in your calculator, just because I can. Where is it? In your calculator. If you want to take a random sample, this is really cool. Okay, I have 7 data values and I need 3 of them. So if you click on this math button right here, now depending on what calculator you have, you might not have this exact number. Sorry, arrow over, arrow to the right till you get to num. Well, actually, keep going till you get to prob. Arrow over till you get to prob. I want rand int no repeat. This means I want random integers and I don't want anybody to repeat them. I don't want any numbers repeated. So I'm going to go 1 to 7 and I want 3 random numbers. So I'm going from 1 to 7 and I want 3 random numbers. I'm going to hit enter. It gave me 1, 7, and 3. So now when I go back to my other page, if I go the right way, I want 1, 7, and 3. These are the three that I'm going to use. 23 plus 23 plus 43. And these are the ones that I'm going to add up and take my average of. 29.7. Yep, I can show you how to get there again. All right, well, that's the wrong way. If I can get to my calculator, woo. Okay, so clear. Ah, maybe if I can get my calculator, hit the math button. So right underneath alpha is a button that says math. Hit math, arrow to the right. We want probability up here. So just arrow to the right until we have the list that's with probability. Now, if you don't have the rand int no repeat, you can use this one right here, rand int. It might give you repetition though, so you might have to do it more than once. And then rand right here just gives you any random number, so it's not really useful right now. Rand int no repeat makes sure you don't repeat anything. You're welcome. All right, let's go back. Okay, so 27, now I need to divide that. Oh, I already divided by that. Oh, that's ugly, divided by 3. There we go. Okay, so I got 29.7. So using the X bar, it's really important to show that it's a sample because clearly it's going to be different than the original. This right here would be mu. Like, okay, that's the population. I know that one's accurate. So when I use X bar, people can look at that and know that, hey, that's probably not super accurate. I'm not going to be asking you, I don't believe I'm asking you in any assignment or in the test to find your own random numbers. I just thought that was something fun to do with the calculator. And I try to do that. I try to throw in some fun calculator goodies as we go along. So, all right, moving on. Okay, I would like you to calculate the mean of these ones. These are test scores. So go ahead with your calculator. Like it? Good, 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 good. So with your test score or with these test scores, go ahead and use your calculator to calculate the mean. I'm going to work behind you very quietly. It's such a nice, pretty number on this one. All right, how we do? Hopefully that one wasn't too bad. Hopefully calculating mean, we're feeling okay with it. All right, any questions before we move on? Okay. Let's talk about median. Median is so super important. I cannot even express how important it is. It is so important. So median is just the center of the data. So if you arrange your data from smallest to largest, it is the center data value. It is the one right in the middle. So the first thing you do is you take it and you order it from smallest to largest and you figure out how many there are, and you're going to figure out where the middle of that data set is. And that middle number is the median. Most of the time, there's not really any math involved. You just have to be careful with organizing. I am so bad at organizing things in order. I don't know why. I don't know why I'm so bad at it, but I am. So we just take them and order them from smallest to largest and find the middle. It's really easy with odd numbers, slightly more difficult, but not really difficult with even numbers. Let's move on. Here we go. This is the same data that we had before with our web development company. I'm going to order them from smallest to largest to find our median. I usually cross them out as I go because otherwise I do bad things. I make it really terrible and lose track of where I am. So I cross them out. So I try to minimize that error. See, with 7, it's not so terrible. With larger data sets, it becomes a problem. Right. So I have 7 data values here. Therefore, my center value is going to be the fourth one. It's going to be this one right here. This is the center of my data right there. So I have 3 above it and I have 3 below it. So this is the median. It's that simple. That's the median. Really hardly any math. We use this a lot when our data is skewed. If I have any big outliers, super unusual, I'm going to show you the even number in a minute. A good question though, but I'm going to show you that in a minute. It's not terribly difficult. Sometimes it's a little bit uncomfortable because you end up with something that's not one of your data values, but it's okay. So this is when we're going to have a new data set. We're going to have an even number. So we have a new employee. The new employee, their travel time is 70 minutes. So we're going to find the median of this, and I'm going to show you how to do it once we put these in order. So it should be easier the second time. I shouldn't have errors here. Possible though. Okay. So now I have an even number. The center of my data set is in here somewhere. It's somewhere in there. So I need to find this number that's smack dab in between those two. So I'll do 23 plus 26, that was ugly, and divide it by 2. So you just find the average of those. You just add them together, and divide by 2. So that is the center. So this right here is my median. It is smack dab between those two values. Whoops. Not terrible, right? Questions so far? Are we doing okay? You ready to do one on your own? Okay. Let's do this right here. So this is the length in seconds of a random sample of songs released in 1970. I love that they used 1970. There's some good songs in 1970. We need to order them from smallest to largest. I'll do that part, and then you can find the median. And I'm going to do them down at the bottom, maybe, so I can have some room. And I'm so bad at this. This is where I make the mistakes. I'm also really bad at counting. So not only ordering numbers, but counting. I'm really bad at that. My high school students love to pick on me about that I can't count. Okay, there we go. Go ahead and find the median. Look at that. I gave you 9 of them. I think 1, 2, 3, 4, 5, 6. Yeah. Remember, median is smack dab in the middle. So I'll need 4 above and 4 below. So my median will be 217. Yes, good. Good job. I hope we're feeling groovy. Since it's 1970s, I had to say groovy. Just had to. Okay. Now you're going to do the test scores. This is going to be a little bit trickier. Not much, but it'll be a little bit. I'm going to once again I will put these in order. I wouldn't trust me too much on that, but I'm going to do it. We'll see. That's why I like Excel. It orders things for me. Oh, see, I forgot 84. Here we go. Go ahead and find that median. So since you have even number, it'll be halfway between these two values. Yes, good. 79.5. Great job, both of you. All right, 79.5 is our median there. We don't have a fancy symbol for median. Most of the time we just do MED. I don't know why we don't get a fancy symbol. Somebody should come up with one and make it stick. Nobody listens to me, so nobody would go with my symbols, but we really need a fancy median symbol. It's just MED. I would just do MED. We don't do sample median because that middle number is so important. So we just find that middle number. So you may, I'm gonna talk, never mind. Hold that thought because I have a thought, but I realize that I have a slide later that lends itself better for that. Okay. Any questions on median before we move on to mode? All right. Mode, oh wait, we're going to talk about this first. This is so important. This is our skew. This is an important page. This is an important page. This is a really great one to maybe tab. So if you have like sticky notes or something that you're tabbing your notes, this is a good one to tab. I refer to this slide so frequently. So frequently. I'll refer to this slide in my own work. So super important page. So tab it or whatever you need to do to be able to find it. So if we are skewed left, if our data is skewed left, then our mean will be significantly smaller than the median. Now, I'm not talking about 79 versus 79.5. I'm talking about if our mean was 70 or 68, and then our median was 79.5. So it'd be a significant difference, not just 1 or 2 points. So significantly different, it would be skewed left. If symmetric, bell-shaped symmetric, our mean and our median are going to be basically the same. Notice all of these adverbs that I'm throwing in there. So it's like roughly equal or really close. They're really close to each other. Then we're symmetric, bell-shaped. We're not skewed. Skewed right, our mean would be substantially larger than our median. So if our mean is significantly bigger than our median, then we are skewed right. So this is an important page to keep handy. So I'm pretty sure there's a question on the test that says, based on the median and the mean, what is the shape of our distribution or something like that. So this is a good page to be able to refer to. Right. Questions, comments, queries, concerns? Okie dokie, we're going to move on. Now we're going to talk about, we're going to look at the shape of the distribution based on our mean and our median here. So this is the home prices in Lincoln, Nebraska. I put them smallest to largest, but it doesn't matter because we're not going to calculate them ourselves. Nobody wants to type all those into their calculator. Definitely not me. We're going to find the median and the median, and we're going to talk about our shape of our distribution. We're not, do we draw a histogram? I don't remember. Okay. So our mean asking price, the mean is 168,320. The median is 148,700. So our median is significantly smaller than our mean. So we are skewed right. So that it should be, once we see the histogram, it should be skewed right because our mean is significantly, or sorry, our median is significantly smaller than the mean. Let's take a look. Here's what our histogram looks like. Notice how we have this tail over here. This tail over here shows that it is skewed right because our median is smaller than our mean. So that's what it's going to look like. So it shows you that comparison. I'm going to show you another one. It's kind of ugly because I took it directly out of the textbook, so it's a little bit ugly. These are the birth weights of 50 randomly sampled babies, and it is in pounds. So this is their birth weight. So take a look at the histogram for this one. So this one is slightly skewed. I didn't remember what the actual are. I didn't write down the mean and the median, so it is what it is. But notice how they're both on the same bar there. The median is slightly smaller than the mean, so we do have a slight skew, but they're really close. They're really close to the same, so this one would be symmetric. I can kind of draw a bell over it. Oh, that pink looks kind of pretty there. I could draw a bell over it, and it is, I mean, you could see there's a slight tail over here, but it's not enough to worry about. As I said, we don't deal in absolutes. Statisticians don't deal in absolutes, so this is a close enough thing. We kind of depends on how important what we're doing. If we're building the space shuttle, we want everything to be more like, perfect. But if you're just trying to figure out something about birth weights in babies, you're probably okay with a little bit of slight right skew. All right, questions about that comparison before we move on? All right, I got some cool stuff here. We're going to do the mode. Now, once again, I don't have a really good use for mode. Pretty much I just use mode when I'm dealing with categorical data. Because it's not numbers, we just kind of look at the data and say, yeah, this one is the one I have the most of. That's what the mode means. It's what you have the most of. You can have no mode. So if there's no value, you have nothing you have the most of, can be one no mode. Now, if I have two things that I have equally a lot of, I would have two modes. Call that bimodal. It's a fun word to say. You don't have to remember it, but it's fun to say. And I don't generally see things that are more than bimodal. Usually it's one mode or no mode. One mode, two modes, or no mode. If we don't have observations that occur more than once, then it's no mode. I'm going to show you an example. Okay. I did not add into here, I did not add into here Kamala Harris and JD Vance because I have a nice same length in my rows and I don't want to mess things up. So we're just going down to Mike Pence and calling it good. So these are vice presidents and this is where they were born. So I took their state of birth on all of them and I put them in a frequency table. And you can see right here that New York is significantly more than the rest of them. So my mode here is just New York. That's it. There's nothing more exciting. We generally, as I said, use mode for categorical data. Otherwise, it's not like super important. I mean, it's not something we use a lot. Can you believe we only have one more slide left? That's crazy. Tried to make this one not so long because we have a lab to do. All right. This is another kind of a really good page to, you don't necessarily need to tab it, but you might want to refer to it. So here's when we use different things. So I thought I had another one. No, okay. So the mean so numbers that are outliers, so super large numbers or super small numbers that are far away from the bulk of our data will cause my mean to move quickly. It drags it up or drags it down, and it makes it seem like the numbers, like most people have higher or lower of whatever. For a great example is people will say the average educator salary in, let's say, Oregon, the average educator salary in Oregon is $92,000 a year. People will be like, well, I thought teachers didn't make very much. Man, that's a super high number. Generally, when they do that, they're including people like superintendents and principals and teachers who've been teaching 30 years. And they don't look at the fact that a brand new teacher might make $35,000 a year. So when you have these super high grossing, these people that make a ton of money, it drags that average up and it makes it look like people are making some really good money. Whereas you use median, then it kind of allows those lower values to actually be part of the conversation. So that's when we use median. If we're skewed left or right or have some great outliers, we will use median instead. Mean is for when we have nice symmetric bell-shaped data, then we can use the mean and it's more meaningful. With the median, if we're skewed, have great outliers, we will use the median because then it's a better picture because it gives the middle. You frequently hear median used for home values because I know I live in Grants Pass and we have some multi-million dollar homes. It would drag that average up. Or what if you had a lot of foreclosures in a year? It's going to drag that average down. So by using the median, you're going to see a true average home price. So I said with the mode is basically used for qualitative data. We don't use it a lot for any kind of quantitative, but if you really want to see which observation is seen the most, then you can use mode. So, all right, this is the end of the PowerPoint portion. We're going to do the lab in a moment. Any questions on the lesson itself? We're done with 3.1. I'm going to rearrange here so that I can get to my Excel.
I'm just going to unmute myself instead of trying to type. Do you just develop somehow that intuitive knowing of when things are not quite perfect and that's okay? Like in the bill, because I don't know, it's hard to know.
It kind of is like how important it is to you. Using the mean rather than median happens more with people trying to be deceptive than it does by people just choosing the wrong one. So, for example, with the teacher salary thing, if someone wants you to think that teachers are making too much money in Oregon, they're going to use the mean. They're going to be like, I'm going to use this because it's going to show that teachers are making, $93,000 a year and they're being paid really well. Rather than that kind of just like leaves those new teachers out of the conversation. It's used more deceptively than anything. It depends on how important it is, really. And you could do both. So one of the really cool things about our fancy calculators is we could put the data into our calculator and get the mean and the median out of it. And they will be side by side, and then you can choose.
Oh,
So,
okay.
so I'm going to show you, yeah, I'll show you how to do that in the calculator and it'll be helpful. There are some things that you just know, like housing costs. You kind of know that that's going to be skewed one way or the other. Some of it is just like, yeah, I just kind of know that that's the case. I mean, the weight of babies, I would expect that to be pretty much normal. I would expect that to be symmetric. There's a few things that you can kind of intuitively know, but a lot of it is just let me put it in my calculator and see what it says.
Okay, that's
Oh,
helpful. Thank you.
you're welcome. I'm not expecting you to intuitively know any of it. I'm going to give you tools. All right. So let's go to Excel. I know some of you don't like Excel, but Excel is my happy place. Just letting you know, Excel's my happy place. So I'm going to try to step through this pretty slowly. So you needed three different types of data. You needed categorical data, 20 data values of that. You needed continuous, 20 data values of that. And you need discrete, 20 of that. If you do more, it's not a big deal, but please don't do less. So I don't want to mark you down points for not having enough. So I think the lab instructions itself says you need 50, but your reward for actually listening to me is that you only have to choose 20. So I'm going to start with categorical. So what did I asked 20 friends on Facebook what their favorite color is. And then this is my raw data. I want your raw data. This is the raw data. I just typed them in here as they were given to me. This is the raw data right here. My population is my friends on Facebook. Now, you need to be really careful with your population. So if you chose a bag of M&Ms, the bag of M&Ms is your population. If you sat on your front porch and watched cars go by, it gets cars on your street. Um, you got to be careful. Your population is not your variable. So I wouldn't say my population is friends' favorite colors. That's not my population. That is my variable. So that's what I'm going to type here. It says, why are you interested in the population and variable? I don't think you're interested in it. You don't have to type anything about the why you're interested. I'm not expecting you to be interested. Not until your final project. On your final project, I expect you to be interested, but not on this. So just say what your variable is. My variable is my friend's favorite colors. That is it. So on units, you could either say that there are no units because there really are no units, or you could just say colors. I will accept either one because the units are technically things like feet, yards, miles, degrees, inches, all of that. But so there aren't really units here. But if you said the units are color, I'll accept it. Or you can just say not applicable or no units. I'll take either one. So on letter D, why are you sure your sample is categorical? I'm looking for an explanation of how your variable fits the definition of categorical. So you might have to go back in your notes and look at the definition of categorical and tell me how your variable fits that definition. That's what I'm looking for there. How does your variable fit the definition of categorical? So here, how did you get your data? Just tell me. And I don't care about this second question here. Explain how well it represents your population. I don't care about that, but I do want to know how, where you got your data. I asked my friends on Facebook. You can say, I went to NFL.com. Say, I opened a bag of M&Ms and dumped them out. Whatever you did to get your data, that's what you're putting there. But do not say Google. Google is not a source. Say whatever website Google sent you to. Google is never a source. That's one of my pet peeves. I have a few of them. As I said, type A personality. Type A's always have pet peeves. That's one of them. If you're a type A, you know. So let's do a pie chart. The first thing that you're going to need to do is you're going to need to count. So we all know I can't count very well, but here we have it right here. So I put each different outcome that I got, and I counted how many each have. So this is my variable, and this is the frequency. I created a little mini frequency table here. There are ways to have it auto-populate, but I don't feel like we need to go that technical with Excel because it is a little bit more in depth and tricky. And I feel like I'm just going to let you guys count. I'm not going to teach you the tricky ways. Okay, so now what we're going to do, we're going to create a pie chart. I'm going to highlight. So the way that you highlight is you just click on it. With your clicker down, you just drag it over the whole thing. So I'm highlighting this, all of this. I don't want the X and the F highlighted, just all of my data and the frequencies. So highlight that, then click on Insert. And most of the time, 99 times out of 100, the chart you want will be in the recommended chart. See, pie graphs right there. If it's not, you see little pies, yours might look a little bit different than mine, but you're going to have a spot with charts and there will be one that's a pie. Now you can have a little bit of creative freedom here with your pie, but I'm just going to get a regular one. I'm going to put this here and I'm going to do some finagling, fixing things a little bit. So the first thing I'm going to do is I'm going to change my chart title. First, wait, actually, before I do that, I'm going to show you, hold on. In chart design, you can play with it. I want one that has percents. I forgot to show you that. You want one with percents. Now you can pick any pretty cool one you see. There's all sorts of really neat ones. Have fun with it. This one's weird. If just find one you want percents on it. If it doesn't have percents on it, you can add a chart element and um, you can get stuff there. But just pick one that has percents. Just makes it easy. So whichever one you like, I'm going to choose. What do I want? Okay. Oh, okay. We're just going to go there. All right. So I'm going to choose this one right here. Okay. Now I need a chart title. Just click up here. I'm going to just double click up there and I'm going to type in friends, favorite colors of friends. I don't care what it is as long as it goes with your variable. So just make sure that you put that up there. All right. So now I have an issue here. I do not want blue on my red pie slice. Now you might want blue on your red pie slice, but that kind of annoys me. I'm going to double click on the body of of my pie here. And down here where it says colors, uh, 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 I don't think that's where it is. Okay. I think it's on colors. Okay, this color right here, I'm going to click on the blue one. That color right there, I want it to be blue. I'm going to click on the green one. That color, I'm going to make it green. Oops. Click on the purple pie. I want it to be purple. So I'm just, I just clicked on the whole thing instead. Darn it. I'm going to undo. Control Z. Okay. I'm going to click on just the purple slice and not the whole thing. Change it to purple. Click on just the brown slice. See, I clicked on something else. Click on just the brown slice. Do I even have a brown? I need more colors. There's a brown. Okay. Uh-oh. I did it again. Okay. Just the brown slice. Notice, see, you can see I have the whole thing. Hold on. You could tell that the whole thing is clicked because I have all of these little dots right here. So if just the brown slice, it's gonna be just the brown one has these little weird dots right there. I need a brown. We're gonna call that, nah, it's not brown, but we're gonna call it brown because I don't want to waste time. Click on the red slice, make it red. See, I'm just trying to make it pretty. I don't, I'm not gonna mark you down for not pretty. The things I will mark you down for is not having labels, not having percents, and not having labels, not having percents, and not having a title. Those are the things I'm going to mark you down for. So I want the percents, I want the title. The key will show up automatically. I have had people somehow delete the key, and I don't even know how you do that, but I'm just saying it happens. So that's what on your pie chart itself, not having percents will get marked down for, and not having a title, and if you delete your key. All right, questions about categorical before we move on? I'm letting you know this is the longest lab of the whole of all 5 labs we do. This one's the longest. The rest of them are easier and quicker. Okay, next we're going to go to continuous. I got a little ambitious and I have 100 something data values. You don't have to do that. Mine is magnitude of earthquakes. And I keep thinking I'm going to change this, but I can't think of anything else I want to do. Now, there's a couple of things. There's one thing that I'm going to get rid of on here. You don't have to do, but let's talk through here. So this is the magnitude of earthquakes in the world. So my population is just countries of the world because each one of these is a different country. My population is countries of the world. My variable is magnitudes of earthquakes in countries of the world. My units of my data, and this is one of the reasons I don't like my variables because magnitude doesn't really have units, but 99 times out of 100, your continuous will have units. It might be feet, it might be inches, it might be degrees, it could be kilograms, it could be whatever. You're going to have units. So make sure you put whatever your units are here. Units are whatever unit of measure it is. This same thing with categorical. I want to know, how do you know your sample data is continuous? You need to tell me how your variable fits with the definition of continuous. E is the same thing. How did you get your data? Now you do not, this is the part you don't have to do. This, I'm going to highlight it right here. You don't have to do that piece. Excel used to not do bins very well. And so it's improved a little bit. So you don't have to do this piece. I do want this, where the determine your interval width. I want that, but you do not have to give me this table right here. Okay. Histograms can be a little bit trickier. I'm going to walk you through it as quickly, as slowly as I can. I'm going to highlight all of my data. There's a lot of it. I'm going to highlight all of this. There we go. I'm going to highlight all of that, and then I'm going to insert. And as I said before, the recommended chart will be there. Most likely, the recommended chart will be there. So it's right there. If it's not, you can see one right here. Click on histogram. It is so ugly when you start. Notice that Excel decided for me what my bin width would be. If you decide you want to just choose the one Excel has, I would have to calculate what that bin width is and then just type it in this box up here. I don't like their bin width. So go into your, I'm going to click on this and go to the chart design, play with it. Here's colors. If you like these colors, however you want those. There's different interesting things here. Choose that before you make any other changes to your table, because you're going to lose everything. As soon as you change your chart design, any other thing you did just disappears. And it's very sad. So I'm just going to go with a pretty typical one here. Okay, you need to add axis labels. I need to have a vertical and a horizontal axis label. Well, first thing I'm going to do is change my title. Earthquake magnitude around the world. I don't know. I'm just making stuff up. So up here in the top left, I can't make it bigger. It won't let me make my bar bigger. Up the top left of your screen, it says add chart element. There's a drop down there. I'm going to go to axis titles. I want a horizontal axis title. Go again, axis titles. I want a vertical axis title. This I can make bigger. So here I'm going to type in magnitude. Whoa. So whatever your variable is, it's magnitude. Your vertical, everybody's vertical will be the same. Frequency. Everybody's vertical is going to say frequency. Get rid of that. Okay. All right. So let's say I don't want I don't want this to be my bin width. I do not want that to be my bin width. If you double click on the chart right here, if I double click on that, I wanted the whole thing. Okay, double click. Okay. I double clicked on my histogram. Now, you remember back on the back with the pie chart, I could either click the whole thing or I could click just one. You need to make it so that you're clicking the whole thing. And I'm trying to figure out how to do that, how to tell you how to do that. I believe it's like clicking between the bars. So you kind of click between the bars and because you want this. See this thing right here that shows bars right there? I want that. So might be a little trial and error. I had to kind of click between the bars to make it work. So I want my bin width. I'm going to change my bin width. I want that to be 0.5. Now, if you do this and you end up with something funky, so I'm going to make this smaller. I like the number of bins I have, but let's say you did this and you ended up with 3 bins and you want more. Change this. So maybe I want to make it 0.8. Okay, that's good. Or maybe I want to make it, if you only have 2 bins, you need to make it smaller, 0.2. Uh-oh, I have way too many now. I like 0.5. So play with that number till you get what you like. Now, if you did one and you have like 3 blank ones in a row, you're going to want to change that. So just play with that until you get it to look the way you want it to look. I like mine. I think it's pretty. I'm going to leave it there. Okay. So remember the whole pretty versus and meaningful thing? I hate that this starts at 4.4. So I'm going to show you something that I do to make it pretty. It's still meaningful, but it's pretty. I want my lower bin width here to be 4 because that's the first pretty number below 4.4. So I know that my lowest data value is 4.4. So what I'm going to do is I'm going to type 4.4 over here so that I remember it. It's not used for anything. It's just reminding me that number is really 4.4. I'm going to change my smallest number to 4. Take a look at this gorgeous histogram now. It doesn't really change the meaningfulness of my histogram because it's still in this bin. It's still in this bin. Because it doesn't matter what the numbers are as long as we have the right number of them, the right frequency in the bin. So now I have this beautiful, beautiful histogram with pretty numbers. You don't have to do that. This is just me liking it to be pretty as well as meaningful. So you don't have to do that, but make sure that you put the true number right next to it so you don't forget. And so that when I'm looking here, if I, for some reason I was judging you on your numbers, which I rarely judge on numbers, that way you're just like putting that placeholder there. All right. Questions on continuous before I move on?
So I think maybe you've addressed this, but somebody told me that we're not supposed to have those lines that go horizontally in the background.
You don't, you can or
Want
not.
me to get rid of those? Do you care? Like,
No, no, you can, you can have those if you want. Those are just fine. If you
okay,
don't want them, you don't have to have them. It's really a stylistic choice.
okay.
Yeah. So I wanted them, so I have them.
I
And
kind of like them, and I was like,
yeah,
but this person was telling me to get rid of them.
no,
So
so in chart design, they're like, for example, this one here, you barely see the lines. And I actually think that I think there's probably even a way to do that. Let me see. I think there's a way to do that. Format. I don't know.
it doesn't matter. I just was
Oh,
curious.
there. Yeah, this would get me without it, probably. I'm sure that there's a way. I'm sure there is, but I like them because it's easier to see. I mean, I personally like them in there, and I know that there's ways to get rid of them, but just leave them in there. They're pretty.
Okay.
Pretty and meaningful. Okay. Discrete data is the quickest one of all. All right. So my discrete data is I took a bunch of friends and just looked at how many children they have. So that's what my discrete data is. My population would be my friends on Facebook. Once again, I don't care why you're interested. You're probably not. So I just want to know your variable. So my population's friends on Facebook. It is not my friends' kids. It is my friends on Facebook. My variable is how many children each of my friends has. Now, once again, with units, there's really not units. If I wanted to say the units are kids, that's fine. I won't mark you down for it, but basically there's not units. I want to know how does your variable fit with the definition of discrete? That's what I want to know. That's what you're telling me in this box. E is the same. How'd you get your data? Where'd it come from? So you can organize your data here. What I have is the outcome, so the number of kids they have, and then frequency. So this is just my frequency table. You can use whatever graph you want. So you are choosing a graph that displays your data. You could reuse a type you've already used, or you can use a different one. You can be creative. You can use whatever you want. The goal here is for you to go into these charts and try some different ones and see until you find one. The number of songs on an album is discrete, yes. And the number of chapters in a book, pages in a book, yeah, those are all discrete. That's good. Good choices. So you are just gonna You are going to just choose a graph that meaningfully shows your data. That's what you're doing. Whatever graph you want. I've seen lots of different things. If you just want to use a pie chart again, go for it. If you want to use a histogram, go for it. Whatever you think does. There's so many different types of graph and they can be fun. So choose whatever you want. I want to see your interpretation. That's it for the lab. Are there any more questions on the lab? Okay. Any other questions about anything else while we were still recording? All right, I'm going to turn the recording off. That's not what I wanted to do. I've hit the wrong button. Okay, stop recording.